Hi guys, I hope you all are doing well. Today I'll be giving tutorial on coding modeling on PVsyst software for grid connected system. So let's start. On opening of PVsyst software, so we got options to simulate a grid connected system, standalone system, and a pumping system. For today's video, we are designing a grid connected system. So just click on grid connected. Yeah. On After clicking on the grid connected option, we got a new uh, window. Here we have to put our project's name. Let's just put test for now. After that, we have to select a site file for our system. We can directly put coordinates over here, or if we know the location, we can also put that one. For now, I'm just putting a random location from Google Map into the PVsyst software. You can choose any location for your practice. Select the coordinates and then just paste here and then search. It will automatically select the nearest meteor station that is near that location. Yeah. Here you can see the site name, the country, it automatically detects. Here on the meteor data import, so we have different databases for the meteor data. Generally, we use the Meteonom 8.1, so we are just selecting this, click and then click on import. So here you can see we have meteor data for all the months of the year. Yeah, just simply save this one and then save. After selecting the meteor, we have to save our file. Just click on save. Now we got onto our main options to design a PV system. So here we have the variants. We can design different variants over here. So now here we can also copy our variants, rename it, or move our variants up or down in the list. Just cancel it. I'm just renaming this as a revision 1. Now just open the orientation tab. Here you can see we have various options for the fixed tilt, a single axis tracker and dual axis tracker. For now we are just selecting a fixed tilt plane, then we have to select the tilt angle. It will be any angle that you want. You can also see on the right side, after changing the tilt here, it shows graphically onto the right. Yeah, and after that we have to select azimuth. So by default it is toward 90 degrees south. It is so after selecting the plane tilt, we have to select the azimuth. By default, the azimuth is true south. If we have to change the azimuth, then we have to add it up to the 90-degree increments if we want to face our modules to the west, and up to minus 90 degree if we want to face our modules to the east. So now just put 90. You can see our modules are facing to the west side. You can see that the red dot is representing the upper end of our module and the blue end is the lower end of our module. So this is how you can also check if azimuth is correct. For now, we are just simply select any angle in between south or west. That will be around 20 or 30%. So here we have of the plane tilt and plane orientation. Just simply click OK. We have to save our project. Then we have to define our system. Just over here. Yeah. We can change our area's name. If we have different buildings, then we can name it as buildings, or we can also name it as different areas, area 1 up to n numbers. So now I'm just putting here area 1 And also we can either we can manually size or we can automatically do this by just putting the desired kilowatt power over here. For now, we just manually designing our system. So over onto the PV module options. So we have number of options over here. For now, I'm just selecting the JS Solo. You can choose whichever module you want and the voltage as per your convenience. I'm selecting 450 module over here. We can also check its parameters from the open tab option. You can see the short circuit current, the ISA, the IMP, then the VOC and VMP values over here. We have also options to check the size and technology of the module, the model parameters, the additional data, commercial and graphs. These this all data is from the manufacturer and it is not advised to change it as it will then reflect in a modeling result. So just keep it as it is from the manufacturer. After selecting a module, then we have to select a inverter. So I'm going now with the chin power. You can select any inverter manufacturer from here. But I'm just going with the chin power. So selecting the manufacturer, then we have to define the model number that we are going to use in our system. So in PVsyst, we get option to use the multi MPPT feature. If you disable it, it will just simply shows how many number of models are we going to use. But if you use the multi MPPT feature, then by using multi MPPT feature, we can use different string lengths on the different MPPTs of the inverters. Also, if we increase the total MPPT input numbers, then it will reflect on the global system summary. It will automatically increase the number of inverters over here. For now, we are just using one inverter, so I'm just putting three and the total number of MPPT. So here I'm putting 10 modules in series and 3 strings in parallel. So it will be a total of 30 modules for my total array. So here you can see that our total DC power is around 13.8 and our total AC power is 10 kilowatt and the power ratio is 1.35. So power ratio should be between 1.1 to 1.4. So we are fine on this one. Just simply click OK. We have to save the simulation. Now we have to define losses for our system. For ohmic losses, we can define the losses by ourselves if we know, or we can just simply click on default. It will automatically put the losses as per the manufacturer's suggestions. We have number of options to define our losses in the system. For swelling loss, we have to put generic value of 3%. If we know the specific value of this oiling loss factor, then we have to put that. Otherwise, we have to just use the default value here. For the auxiliary energy losses. So auxiliary losses are basically if we are using any monitoring devices or any fan for the inverters, then we have to put that loss over here. For now, we don't have any auxiliary loss. Just take the option. Just click on OK and save the variants. So on storage tab, if you are using any battery in our PV system, then we can define the batteries in this tab. But for now, we are not using any battery with the grid system, so we are going to leave this option as it is. Still for Horizon. So in this diagram, we generally use this to determine the production of a project. So if you can see the one line, this is from the 22nd June data, and then the second is the 22nd May and the 23rd July. So like this, we have values at the different time of the year to the seventh number, that is 22nd December. You can see how this aligns from 1 to 7, how these are gradually decreasing, and this will also help in projecting the solar. We can also use this to predict the energy production throughout the year from a project. So in the top left corner, this is behind the plane. So the production will start after this line approximately from the 7 to the 18 hour. If you can see the curve, yeah, over here. So this graph may vary from location to location, and also this blue line is this is variable. If it can be varied, if we the blue line is we can change the production by changing the tilt and the azimuth of our system. So yeah, that's all on this tab. Now just click on run simulation, then on preferred graphs. We have number of graphs. We can choose any one from these if we need. Now just close this option and we have to just save the report now. Then select the option. This is a report. On the front page, we have project name, then the variant, the variants that we are working on, and then if we are defining an 3D scene, that will be reflected over here. For now, we, we don't have any 3D scenes, so it is representing as shading, central power, and the native file. Here we can have a name or company's name. On the next sheet, we have a latitude, longitude, and the Meteo data, and then the system summary, the total number of modules, the total power, and the total number of inverters, the total power, and the power ratio over here. On the next we have the result summary, the total produced energy and the performance ratio. Internal parameters, so we have PV characteristics and error losses that we have defined. On on the load diagram, so here we can see that the total number of energy that we have that so here we can see the total energy that the system is producing, and then all the losses, uh, the IM loss, the volume factor loss, and after the PV conversion, the total power that is generated, and from that power, the loss due to radius level, the PV loss due to temperature, the module quality loss, mismatch loss, and ohmic wiring loss. After that, we have inverter losses, that is inverter loss during operation or inverter voltage, and yeah, stuff like that. You can check this. It the loss diagram will vary from project to project depending upon the losses that we are going to define. Next, we have daily input output and single line diagram. From here, we can say our document as PDF input. Now I'm just closing. So that's all for today's tutorial. For the next tutorials, I'll be showing you how to use the storage with the grid connected system. Thank you all. Let me know in the comments if you have any doubts or if you have any suggestions.